Thank you very much for the introduction, and I'm really happy that I'll be able to present to you a little bit today about my vision really for what the future could look like. So I'm kicking off a whole series of presentations that will deal with the topic of carbon removals. And so I want to start really with a bit of an overview and a bigger picture of how we could really switch from emissions to removals. And you might say that maybe it's a little bit early to talk about removals when, well, we haven't really even started properly to reduce our emissions yet. But I want to convince you that really now is the time to start thinking about this and also to really get into the doing of this. And so what my vision looks like is actually that we can embed these removals into our economy and into every product that we make. So in the future, what I want to do is that if I buy a shirt, I want to buy a shirt that actually has on its way to me removed carbon over the life cycle instead of producing it. And before we get into how we can actually do it, I want to just talk a little bit about what are we talking about here. We hear a lot more about this later on. But essentially what a carbon removal is always has two components. And it's very easy to see on this technical technology that here in the picture from Climeworks, who will also be presenting later. There's an element of drawing CO2 down from the atmosphere and then putting that into as long-term storage as we can, right? And this is exactly what this technology does. It takes the CO2, it concentrates it from the atmosphere into a very concentrated form, and then you can put it away into geological storage, for example, what they're doing in Iceland already at the moment. Now, nature, of course, has been far ahead of us on this and has been doing this forever with every single plant on the planet. So what plants do, and it's a little bit more of a complex process, but they also take CO2 from the atmosphere, they draw it down and they put it into biomass. And that's the leaves, that's the tree trunks, but that's also everything that's underground. It's a huge root system, which we mostly underestimate how big it actually is. And it goes beyond that. It goes into really an entire ecosystem of bacteria and fungi and small animals that eventually convert the carbon into something that is more of a more stable form that is also a longer term storage. So those are kind of the two ends of a spectrum, very technical solution, very nature-based solution. And now there's a whole portfolio of solutions emerging that's in between those. So two of them I'm going to quickly mention because we also hear about them later. One is BECCS, which is bioenergy with carbon capture and storage, and biochar, which has also already been talked about today. And they both also start with plants, and then they use this biomass and either generate energy from it by burning it or incinerating it, and then capturing the CO2 and putting it into storage, or they convert it into a coal type of product like a biochar that is clean enough that you can actually store it back in soils. Plus, those are two examples. There are many, many more technologies actually emerging, which we don't have time to talk about today, but it's a very interesting field of innovation, I would say. Now, the next question is, how much do we actually need of that? And this is a very simplified version of a chart where this has been calculated by the IPCC in their 1.5 degree report. And they say up to 1,200 gigatons until 2,100, the end of the century. Now, that doesn't tell you a whole lot, but what it means is if you look at our emissions today, which is what we see in gray, we have a goal to go. What we need to do is actually to reduce them as fast as possible. And we need to go to net zero by 2050, right? And to do that, we also need to ramp up as quickly as we can those carbon removals in red. And eventually, at the end of the century, we will need removals that are, depending on scenarios, somewhere between 10% and 50% of what we're emitting today. So this is a tremendous amount of removals. And it really means, it shows us that we need to embed it into our economic activity, right? So everything we do needs to lead to removals. What I also want to say here is you can see it's how quickly the steep down the mitigation part also goes. So we need to, at the same time, very aggressively reduce emissions to get there at all. And the less aggressively we reduce, the more we need to eventually ramp up those removals, which will make the task even more challenging. So back to my vision and my carbon removed shirt that I would like to buy very soon. So what does this value chain picture actually look like? So today what we're doing is with every step of the way, we're stacking and stacking emissions, right? It starts with the raw materials. We're getting the fibers, for example, from cotton production. There's a lot of fertilizer involved. There's a lot of soil destruction involved that emits carbon. So we're already there starting. Then we go into production. There's energy that emits. We have packaging. We have transport every step of the way. And then eventually at the end of life, we either put it in a landfill where it decays, or we put it into incineration where the contained carbon is released. And we end up with a pretty big footprint. And what I would love to do is actually to flip this whole picture around and say, what we want to do is with every step of the way, we want to go either zero or actually into removal so that we have a final value chain that removes carbon. Now, this is very easy to do in PowerPoint. Any of you could do it. It's a little harder in reality, but I want to show you how it could actually work, that we embed emissions into such a value chain. And we have a lot of technologies for that. So starting, for example, with the fiber production, with every agricultural value chain, with every bio-based raw material, we have regenerative agriculture as a means where we can really do the same process that we want to see in these forests, that we actually build carbon into the soils and that we create these ecosystems in under the soils that stores carbon and really draw it out of the atmosphere. We also have new opportunities to create biomass, and you see on the right-hand side one of the very quickest growing plants on the planet. Actually, I've seen my first live ones really in Ireland, so it's beautiful kind of to see seaweed. You can use it for many things. You can eat it. You can extract pharmaceuticals. You can make plastics out of it. You can make fiber, animal food, fertilizer, and you can use it for carbon removals. So very versatile plant and capturing a lot. And then of course we have the technical opportunities. So on the left-hand side, you see a technology that we also hear more about in a little bit from Neustag, a company in Switzerland that came out of the same institution where I'm working at from ETH. And they have a technology to take rubble from concrete, from used concrete, from buildings that have been torn down, and put CO2 into it, and that with that really create removals, and it can be used for new buildings. And then on the right-hand side, you see a technology that I think is one of the most overlooked cases for carbon removal, with plants that we already have in our society, and that is from waste incineration, right? So we try not to landfill things anymore because that really also creates a lot of emissions and toxicity, but instead we incinerate it and we really filter the air, but we still emit the CO2. And the interesting thing is that about half of what we burn in municipal waste is actually biogenic. So it comes from wasted wood, paper scraps, from things we can't recycle anymore, carton, food scraps, all of that is an opportunity for carbon removal. So all you need to do, and you see it actually happening in the Netherlands in this plant, it's a picture of an installation like that where they have put a CO2 capture unit onto a waste incineration plant. And in the foreground, you can see the big shiny like towers where the CO2 is stored for usage. They're not putting it underground yet, so it's not really a carbon removal technology in their case. They're putting it into use into greenhouses, but it essentially shows that we have these technologies and that we could really create large volumes of removals with it, because every one of those plants emits in the hundred thousands of tons of CO2. So we have now a bunch of technologies that we can plug into our value chain, and then let's see how that could then be put together to create a carbon removed shirt. And we, again, starting with the raw materials, so we would go for regeneratively grown cotton, for example. Then we would go into production, and by now we have actually reduced the emissions in production. We generate our energy from hydrogen, from renewable electricity, etc. We have packaging where we could use, for example, paper or carton, but we could also use innovative materials like the algae and seaweed-based plastics that you see on the right-hand side. Then we go into transport, the same thing. We have decarbonized it. And finally, we get our shirt, and we love it and use it and wear it for a really, really long time, and then maybe respin it and recycle it into a new product. But eventually it will reach the end of life. And then what we stop doing is actually what you see here in the picture is shipping it off to places like this waste dumping ground in Ghana, where most of our textiles from Europe end up today, where it just either rots or eventually even burns. And instead, we put it into a facility that captures carbon and really locks these removals in and puts it underground. And with that, we have reached that goal of a carbon removed shirt. Now, that is the technical possibility, and I think we really have the technology to make it work. The question is, of course, and we have discussed it also in other sessions before, who pays for this, right? How much would it cost me to actually do that? Will I still be able to buy that shirt once it's gone carbon negative? And I would pose the thesis that yes, we can actually afford it. And I'm bringing you an example from actually the cement industry, and it has also been talked about before, that illustrates how we need to think about this. Because we're working on a project at the moment where you can see to fully decarbonize this material, cement, you can easily reach costs that are a factor 2 more than what they are, 2.5 more than what they are today. And this is a case from Switzerland, where, for example, you would employ carbon capture and you have to ship it off to really far distances to the storage sites that are emerging under the North Sea. So it's a tremendous increase in cost of the material. But then if you look at the flip side, right, you look at a house where a lot of material is actually made of this, right? So there is a lot that goes in, but there's also a lot of other costs that goes in, right? There's the architect, the planner, there is the designer, there are other material, there's the land, there's permitting processes, there's stamp duties, all of that. And eventually, if you look at that, the cost increase from the material is significantly less than 1%. And if you look at all the other influencing factors on housing prices, I would say that we can afford to actually spend this type of money on really saving our planet and our climate. And then there is the other side of the story, right? So where there's cost, there's also, of course, economic activity, and there's entrepreneurial opportunity. And I found a study that has calculated and estimated that by 2050, this market could be worth $1.4 trillion US. So this is if you compare it to today's GDP, that's about 1.6 percentage points of 2019's GDP, right? So this is a significant new sector of the economy that will be formed over the next 30 years. And of course, this has not gone unnoticed, right? You might like Elon Musk or you might not, but he tends to think about the future and to think about technologies that we need. And so in February, he came out with this $100 million worth X Prize. So if you have a technology that can really do something for carbon removals, then this prize is up for grabs. And also from my institution at ETH, together with TU Delft and funded by Climate Kick, we are actually opening up a startup accelerator to help startups go the first steps on carbon removal. And if the entrepreneurial bug has bitten you now, then watch out for LinkedIn, for my LinkedIn posts, because we are going to open applications for that quite soon. And of course, if you're not really an entrepreneur, you don't want to go into this from a technology perspective, I think there's really a lot that all of us can do and need to do in our different roles that we have. And just, I think from everybody, if you think about your jobs and where you stand in the value chain, as we need to transform all value chains and essentially make all products and all economic activity first carbon neutral and then carbon negative with carbon removals, I think there's a lot to do in making this happen. And we have heard it before from the cement industry. Companies like that will not just accept that the cost of their products are going up by a factor of 2 in a very, very competitive market, right? So what needs to happen is that we manage to pass those costs down to the consumers, where they then can be borne by the consumers, because it's actually not such a big deal as it is somewhere in the middle of the value chain, right? And I think we need to resolve these issues and these contradictions. So my suggestion would be that this communication across the value chain and aligning that is a really, really important thing that we can do in our jobs and our roles. The other thing that has been talked about also in the panel with Adrian Bühr is regulation, right? We will need regulations to level the playing field, to really bring in these externalized costs that at the moment those products, those emissions are bringing onto society. And we as citizens, we need to demand those regulations. And then when it finally comes to votes, as it did in Switzerland here a few weeks ago, as you heard, we need to be brave enough to actually say yes, right? We need to have in mind that this change needs to come, that it is actually also an opportunity, that we can afford it, and we need to do essentially the grown-up thing and say, yes, we want this, and we can deal with this. And then, of course, as consumers, we will very soon have a lot more opportunities to vote with our wallets. We will be offered carbon removals for products. We will be offered products that are better on their footprint and are going the steps towards becoming really carbon removal products. And I think we need to also say yes with our wallets on this. And to wrap this up, I think there's a few things that I want to add on a more general overview of how we can make this transition the best one it could be. Because I think there's a tremendous opportunity in this. I mean, first of all, the thing is we need to not forget about, despite all these like very exciting new technologies and opportunities, we all need to still work very, very much on the reduction path, right? So this motto of do the best, remove the rest, I really like. So the two of them really go together, and we need to work on this. Then secondly, we of course have also this tremendous opportunity of the circular economy. Let's really create products that are more beautiful, more lovable, that we can keep for longer, that we can, that are higher quality, so that we can recycle them and really take out a little bit of this pressure of just this accelerated product cycle. So the circular economy is a super tool for this. Let's really use it on top of the technological ways of reducing and removing carbon. The third thing about this is really thinking about all the side benefits. Right? So this is a tremendous economic opportunity, and there are two ways of doing this, right? It could benefit the few, or it could benefit everyone. So this is really a matter of governance, of regulations, and as a society thinking about how we can make that work. And then there's so many other side benefits, right? These technologies and this transition could mean cleaner water, cleaner air, better ecosystems, all of that are things that we could either capture or not. So thinking about that from the beginning with these emerging technologies, I think is important. And the very last thing I want to say, because it's such an important factor in this transition, it's about biomass and ecosystems. And biomass plays a tremendous role here. And living ecosystems are what can help us a lot in drawing down this carbon, besides the technical developments. But we need to make sure that this doesn't end in just growing biomass for in monocultures, but that we really build ecosystems that have so many more benefits than just a plantation, basically. And with that, I would just say, let's do it. Let's get our carbon removed products into shelves, because I want to buy them.
Well, Patricia, thank you very much for that insightful, a very optimistic presentation as well. I hope the world will do as you have directed there, and that we make great headway in this battle to capture carbon and not to release carbon. Before we let you go, you're coming from Switzerland, which is clearly a powerhouse in innovation and in green technology. But I think I heard you say you'd been to Ireland to look at seaweed farms. Did I catch that right?
That's correct, yes.
Okay. Yeah. Okay. Whereabouts? When were you here? And what are we doing in that field? Because it should be on this agenda, and it's not on our agenda. What is happening in Ireland with seaweed?
I think it was about 2 years ago, and it was a conference on seaweed. And indeed, there are seaweed farms emerging. I think mainly on the west coast. Okay. And because seaweed, and especially this big kelp, loves cold oceans, and it loves waves, and basically the Irish seas. And it's a tremendously interesting technology or farming technology, really, for carbon removal.
Well, Patricia, when you come to Belfast, we have a wonderful seaweed linguine, which is seaweed from Rathlin Island. So you're on an open invite to MTech Europe 2022. But thank you very much for being with us this morning. Thank you. Good luck.